So on this day, let's take a gander what we're going to do, and this is just part A. Although our goal is to graph, today we're not going to be graphing, we're just going to be setting up graph situations. So tomorrow and the next day we'll spend more time on that. But the first thing we're going to look at is, first off, what does it mean to be standard form? What is standard form? And second, what are the characteristics of standard form? So here we have a ball that is being kicked, and magically you know the formula for that the ball in terms of time. So x here, in feet. So this is feet. After 40 feet, it's there. 50 feet, it's there, etc. So this is the path of the ball, the trajectory of the ball. And this is the height at a certain foot, and 10 feet, 20 feet, etc. As it travels. So what's the maximum height of the ball? So in this case, we can just look at the graph and get a rough idea of where it is. I'm estimating that the maximum height is right here. Now, you might think it's slightly shifted to the left or the right. So if I were to estimate that, what number would you guys guess right? So we say maybe 45 is a good place to be. So 45 is the x value here. So the question is, what's the y value? So how do we calculate that? Well, I take the 45 and I'm going to substitute it right into the x right there and into the x right there. So let me show that work right here. And we'll plug that all into a calculator momentarily. So I have to square that plus 0.9 times 45. And so the exact answer with my approximate, 45 is an approximation, but this is an exact answer with the 45. So I'm guessing it's about a little bit more than 20 feet high, which is 3 of me plus stacked up. Like we said earlier, we are going to spend some time graphing, but graphing will come later. We're just going to learn about standard form. So the first thing we want to do is review and compare the two, vertex form versus standard form. So by review, vertex form looks like this. Y equals A times x minus h squared plus k. And then standard form is y equals ax squared plus bx plus c. To get from here to here, if you were to multiply this out right here and then distribute the a, etc., you would get to that there. So we can convert between forms, which we won't do at this time. We'll look at those later. So the first thing, a tells me something, and a tells me here. So a, remember that if a is positive, we have a happy face parabola. If a is negative, we have a negative, a sad face parabola. Guess what? Turns out it's the same over there. A is going to be the exact same information here. A tells me if we open up or open down. Good. So in this case, the H and the K together, excuse me, are the vertex. This one gets a little bit more complicated about what it means to find the vertex. So we'll get to vertex in a second, but the axis of symmetry is going to be found by using a super secret formula, and that formula is this. X equals negative b over 2a. You take whatever a is here, a is a 1, a is a 2, a is a whatever, that goes on the bottom. The b, whatever that b is, positive or negative, will go there. We always have to have an opposite in the front here. Sometimes we get a double negative, sometimes a triple. We could get a triple negative. So this will help me find the axis of symmetry. To find the vertex, plug in this answer to the equation. So we'll get to that in a bit. And C also tells me something. C tells me the y-intercept. where the whole thing crosses the y-axis. One other thing that's true for both of these, is that when A is greater than, or so let's go with the absolute value, is greater than 1, we have a stretch. And when the absolute value of A is between 0 and 1, then we have a compression. So let's look at an example here. We're going to find the equation of the axis of symmetry, the coordinates of the vertex, the max or minimum, and the range of the parabola. So we're given this function. As we see, this is standard form, y equals 2x squared plus 4x minus 5. Our first big goal is just to determine, and this can be a mental exercise, of what each of these are. A is 2, B is positive 4, and C is negative 5. In order to find the axis of symmetry, I'm going to use my super secret formula, x equals negative b over 2a. And what we do with that is just take the b here and the a and substitute accordingly. So the b is going to go in the numerator. Notice here that I still have to have the negative there. This negative is still in the front. So beware. Sometimes if you substitute a negative in, it's going to get a double negative to be a positive. And 2 on the bottom because 2 is an A. So negative 4 over 2 times 2. And this simplifies to negative 4 over positive 4. So my axis of symmetry is x equals negative 1. Axis of symmetry is x equals negative 1. Remember, this is a vertical line. You don't have to write this down, but vertical line passing through negative 1. So the x-axis of negative 1, the x-intercept. All right, so now I'm going to take that negative 1 and I'm going to substitute it into the function. Remember, my function was y equals 2x squared plus 4x minus 5. So I just take the negative 1 and substitute it in. Remember, the order of operations says, my first thing I do is GEMDOS, gem being G being the grouping symbols, all grouping symbols first, so inside, there's nothing to do there. Next is exponents, so I'm going to do exponents here. I'm going to multiply that out. So I bring down the 2, and the negative 1 times negative 1 is positive 1. So I squared that. Now over here, I can actually multiply this. Negative 1 times 4 is negative 4. And I'm going to bring down the negative 5 there. Continue to do multiplication. So, GEMDOS. I did grouping already. I did my exponents. I started multiplication right here. I'm going to continue multiplication right there. So this is a 2 minus a 4 minus a 5. And lastly, add or subtract. And when you add or subtract, just go left to right. I'm going to subtract these as we go. So 2 minus 4 is negative 2. Minus 5 is negative 7. So here's my vertex. X is negative 1. Y is negative 7. So that's the vertex. So let's review here. How do we know if it's a max or a min? Well, remember the A is the most important part here. So the A is 2. We know that it opens up, which means the basic shape looks like this. So therefore, my vertex has to be a minimum. So don't be confused. Just because there are negatives here, that doesn't indicate whether or not it's a max or a min. It's going to be this scenario. So my vertex is negative 1, negative 7, and it's going to be a minimum because of the negative 2. Next, we do have to find out what the range is. And the range, since it opens upward, and the lowest it goes is negative 7, my range has to be y is greater than or equal to negative 7. Again, as a reminder, your domain for quadratics will be all real numbers. Now, go ahead and turn the page and start working on these problems. And I highly, highly, highly suggest that you go to Desmos and check all your answers. Once you enter this into the calculator, you can just tap the vertex so you can check your answer. And of course, the axis of symmetry is going to be the vertical line that goes through the vertex there. So, yeah, check everything with Desmos. Ciao.